Okay, so hi everyone and welcome to today's lesson. Today is the 19th of May and as you can see today is Calculus Part 1. So I'm really glad to see that the numbers have, they are increasing. So welcome to everybody who's joined on this Thursday evening. We have a 1-hour lesson where we will be talking about specific topics regarding calculus. So what are the things that we will be covering today? Okay, so today I am going to talk to you about the derivative or differentiation from first principles. And thereafter, we're going to spend some time discussing basic differentiation rules. Okay, so as usual, I would like to mention that I'd like this lesson to be as interactive as possible. So please ensure that you have access to your chat box and you can type in yes or no, or type in to let me know if the lesson is too fast, too slow, or whether you did not understand a certain concept. Let me know, and we can work towards ensuring that by the time we end today, you would have mastered the concepts that we are covering. Okay, so these are the two things that I'm aiming to cover with you today. We will go through the basics on our own, and then we will aim to answer some questions that appeared in a past paper from last year. Okay, so to begin, in order for us to talk about differentiation, what we need to do is have an understanding of limits. So have you covered limits in class already? I'm assuming that you would have, since you started calculus, isn't that so? You've come across limits? Yes or no? Let's take a look. So as we're waiting, okay, wonderful. We've got our responses coming through now. Yes, wonderful. So we have covered limits. And typically what we encounter, so just to refresh your memory, when you come across something like this, the limit, as for example, x approaches 0, all right, or it could be any number, any number a in there, of f of x, sorry, as the limit as x approaches a of f of x equals to some other number L. Okay, so essentially what's happening here is we having x approach a, meaning that x will become arbitrarily close. It gets closer and closer to this number a on the axis. So if this was, for example, the x-axis, so let's draw this in a much more prettier way. So let's try and get it straight. Okay, so if this is the x-axis, and here is my number a on it, then the idea here is that we want x to get closer and closer, the value of x to get closer and closer to a itself. So it approaches from the values to the left of a as well as from the values from the right of a. So that's what we mean when we say x tends to a, okay? And so when x tends to a, essentially what's happening here is that the value of f of x is tending to L. So f of x, the limit of f of x equals to L as x approaches a. And so that is the notion of understanding that I require you to have before we talk about the differentiation. So how to differentiate a function from first principles. So you must have an understanding of what is happening. So just to give you a better idea, let me extend on this diagram here. Okay, so let's say this was the y-axis, and let's say that this is my function f of x. So L is a number on the y-axis. So this is exactly what's happening. What's written down here algebraically, the limit as x approaches a of f of x equals to L is depicted here in this diagram. As x approaches a, as x goes towards a in this fashion, we then see that f of x is approaching the value of L. And so diagrammatically, graphically, that is what this sentence in here captures from this picture. Is everybody understanding that quick summary that I was able to give you? Okay, so I need you to ensure that you understand what it means when we say that the limit as x approaches a of a function equals to some other number, for example, L, as seen here on this slide. Okay, so I'm just looking at our chat box to see if we're all good. Right, so I see that we are utilizing both the chat box and the Q&A. So for ease of reference for me, since I can only check one at a time, I prefer for you to put in your responses in the chat box. It does make things much easier for me. Okay, so this is sort of what we need before we begin. And now let's start off talking about our motivation for differentiation. All right, so if I had to give you a straight line, right, so this is a straight line. Do you know how to calculate the gradient or the slope of this straight line? So I'm coming back to our chat box to quickly double check. So what is the gradient equal to? Right, we have encountered this when, well, we refreshed our memories on this when we dealt with analytic geometry at our last lesson. Right, so when we have a straight line, we do know how to compute its slope or gradient, isn't that so? And we have a formula that says the following: y2 minus y1 divided by x2 minus x1, where of course we are utilizing the two coordinates from the given line. So if this was coordinate x1, y1, and if this was coordinate x2, y2, we can utilize those two coordinates to calculate the gradient of this line. And regardless of which 2 points we pick from this line, when we calculate the gradient remains the same, because those points came from this picture that we see here, this line that we see here. So I'm sure everybody agrees with me up to that point. But now, what happens if I don't want to determine the gradient of a straight line, but I want to determine the gradient of some arbitrary curve? And this is a curve, right? So this is some okay, let's do it like this, right? So of this f of x. So I give you this graph and I want to know, well, how do I now determine gradients of this graph? Well, of course, what's going to happen is the question now has to be modified, because this curve clearly has different gradients as we proceed to look at various points on the curve. So what happens is we now tend to ask, what is the gradient of f at a point x? Okay, so the question is modified, but the essence of the question from this scenario to this scenario is essentially the same. We're still interested in determining what is the gradient, okay? So how do you think we're going to go about doing this? So since we know confidently how to determine the gradient of this straight line given any 2 points, why not use that same strategy when required to find the gradient of this curve at a given point. So that is essentially the thinking behind this. And that's how we are going to come up with a definition or a formula for calculating the gradient of an arbitrary function for a given point x. Okay, so arbitrary function, but of course, in our two-dimensional case, as we restricted to in grade 12. Okay, so is everybody following up to this point? Is everybody understanding my motivation? That's what I want to quickly check. Right, I'm looking at the chat box. So I hope everybody's present, everybody's following. So now I'm going to go in to further explanations about how we're going to get out this formula. So I'm going to show you how to derive the first principles formula to determine the derivative. Okay, wonderful. So I see we are following. Thank you for the responses. Okay, let me get a new page. Okay, so I'm going to start by drawing a diagram. So here is my y-axis, here is my x-axis, and here is my curve. Okay, so this is my curve f of x. So we want to determine the gradient at a given point. So if this is a point that has x coordinate, let's call this one x, okay? I'm going to call that x. Then, of course, I do not yet know how to determine the gradient of f at this point. However, utilizing what we've learned before, we can calculate the gradient when we have 2 points. So let's pick another point. And so this point, what we're going to do is we're going to pick it such that it is h units away from x. Okay, so the distance between x and the new point is h units. So what is x plus h? That is precisely what we're going to call that point. Is everybody clear on these two x coordinates that I have now put in there? Perfect. I see from earlier that you've all said that you are following, so I'm glad. Right, so now that I have these 2 points, what I can do is I can draw a straight line between it, right? Because I've picked the corresponding coordinates x and x plus h, where the distance is h units between them. And let me draw a straight line that is now going to join these 2 points. Okay, wonderful. So that's what I've got, a straight line passing through those points. So before we go on to talk further about this, let's discuss what the corresponding y values look like. So for the coordinate x, the y value is just going to be f of x, right? And for the x coordinate, the x value x plus h, the y value here, the corresponding y value from that x value is f of x plus h. So I think we're all good. Wonderful. And I see some of you have put in the answer for me. Right. So this is what we have. Now it's clear that we know how to determine the gradient between those 2 points, isn't that so? So I'm just going to label that there. So this line, this pink line, it is a straight line that passes through 2 points on the curve. What do we call such a line? Do you remember what we call it? A straight line that passes through exactly 2 points on a curve. It's a secant. Okay, well done. Right, so this line is called a secant. So we can essentially calculate the gradient of the secant. Isn't that so? So what is the gradient of the secant equal to? Remember, we have our formula for gradient. It is the change in the y over the change in the x values. So I have 2 coordinates. I've got the first coordinate x comma f of x, and I've got my second coordinate x plus h comma f of x plus h. So the gradient here is going to be f of x plus h minus f of x divided by x plus h minus x. Do you all agree with that? Great. So we've got some responses in there that we're all happy with that. Wonderful. And what do you observe is happening in here? Isn't the denominator going to be, can be written down in a simpler way? Because we're clearly going to get in the numerator f of x plus h minus f of x. I cannot change that, but the denominator is now simply h. So the gradient of the pink line passing through those 2 points is now given by this formula. Okay, so that's what we have. But remember, this is not what we wanted to calculate. That was not the question that I had started off with. The question is, how do you determine the gradient for this curve at a given point? Now, the point that I am interested in is x. So that's the point I'm interested in. So the idea is that we plan to do the following in order to determine the gradient of f at x. Okay, what we would like to do is we would like for x plus h, so this coordinate here, to get closer and closer to x. That's what we wanted to do. We want the distance between the 2 points to become as small as possible. That's the idea that we've gotten here. And so think about this. If the distance between the 2 points is becoming smaller, if x plus h is tending towards x, then what's happening to the value of h? So let me write that down. If x plus h tends towards x, then what can you tell me about the value of h itself? So if I'm making that coordinate get closer, extremely close as possible to the value of x, what is happening to the distance between the 2 points? The distance was labeled h. What is happening to h? Can you see that h is getting smaller and smaller? It's getting closer to 0. So if these 2 coordinates, x and x plus h, become exactly the same coordinate, then essentially the distance between them becomes 0. So as x plus h tends towards x, the distance between the 2 points tends towards 0. Right, wonderful. And I can see in the chat box, we've got someone saying, yes, the distance is decreasing. Wonderful. And so we summarize that mathematically by me stating in here that h is tending towards a value of 0. The distance h is becoming 0, right? Close as possible to 0. That's what I'm trying to instill here right now in your understanding. So now let's pretend that this is now happening, that the distance between the 2 points are becoming smaller and smaller. It's tending towards 0. So if that actually happens, then what we end up dealing with is the following. So what happens is that we have a straight line that passes through the point x only. And what do you call a straight line that does that? Wonderful. So I see the responses, tangent, right? So then we end up with a line called a tangent. So essentially what's happened in this story is the following, that as the distance between x plus h and x became smaller and it tended towards 0, the secant line has dropped and occupied the position of a tangent line, such that that line only passes through one point, and which point does it pass through? It passes through the point that we were interested in, which is X. Can you visualize that happening? So imagine that this was like a GIF, and you could see that secant collapsing into the tangent. You could see that happening. So you could see that you're no longer utilizing 2 points to calculate the gradient of the straight line. You're now essentially utilizing 1 point to determine the gradient of that straight line. And there's a motivation behind how we're going to determine that gradient of the straight line, because what's happened in order for that? H has tended towards 0. Do you see that? So I'm hoping that you all see what has happened in this derivation. We're not done, but have you followed up to this point? Do we all understand how we determine the gradient of the secant? Did we all understand how we want those 2 points to become 1? The distance between them must become 0. It must tend towards 0. That's what we're aiming for. And when the distance between them tends towards 0, the secant line becomes a tangent line. Wonderful. I see lots of yeses in the chat box. I'm glad that we're all on the same page. So now, when h tends to 0, that secant line drops into a tangent. And so now we can ask ourselves, so what is the gradient of the tangent line? So based on this relationship that we've just looked at, the gradient of the tangent line is equal to the limit as h approaches 0. And you now know why we're saying h approaches 0, because what caused us to get the tangent? We had the distance h become so small that this coordinate approached that one. Okay, and this is going to be the limit as h approaches 0 of the gradient of the secant. But what is the gradient of the secant? Well, we've calculated it. It's written above. It is the limit as h approaches 0. Okay, so I'm just copying that there. But what is the gradient of the secant? It is f of x plus h minus f of x divided by h. And this is essentially the derivation that we were all heading towards. Okay, and so this here is what we refer to as, so this is telling me what is the slope or the gradient of f of x at x, because that's what we did. We focused at point x. That's where all of our attention was. And so this formula that we've derived here at the bottom gives you the slope of f at x. And we typically write this down. So this is the derivative of f at x. This is your first principles formula. So notation, this is written as f prime of x. And so we have in general, insert a new page, that f prime of x is equal to the limit as h approaches 0 of f of x, oops, plus h minus f of x divided by h. Okay, so is everybody happy with the explanations that you've received? Did you all understand how we come to this formula? And now do you understand how this formula is related to slope and gradient of a curve? Wonderful. So I'm liking the responses we're getting. Thanks. Okay, so now let's look at examples. Okay, that's what we're aiming for. We want to know, how do we utilize this? Right, so if somebody ever asks you to calculate from first principles, they are telling you to utilize this formula. So this is your first principles. formula. Make a note of that. Wonderful. So let's say I said that f of x is equals to 7x. So this is a function that I've given you. You could draw it on your xy plane, and you could essentially attempt to find the slope to that line on your own. Right? But let's verify using our first principles method whether we would get back the same values that you would get if you did it on your own, because this is a straight line. You know how to determine the gradient of the straight line. But let's utilize our techniques. Okay, so how do we go about doing that? So we need to evaluate the limit of, and in the numerator, we've got f of x plus h. So let's calculate what that would be. I need f of x plus h, but that would be nothing but 7. And in place of x, wherever we have an occurrence of x, you replace that occurrence of x by this input, which is x plus h. And so now we simplify. So this is just 7x plus 7 times h. Wonderful. So we want to find, the question is, find f prime of x. Okay, so the first thing you should do is write down your formula. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. That's what we've got. We now substitute in. Now, some of the things that I've noticed before with students is that you tend to drop off the limit from the left-hand side. Remember that this is crucial to your calculation. Okay, so don't just focus on inputting things into the fraction and simplifying. Ensure that you carry through your limit all the way through to the end of the calculation until you reach a point that you could drop it. Okay, so remember that. So now let's plug in f of x plus h. That answer is just 7x plus 7h minus f of x, but that is just 7x divided by h. So in the next step, we now simplify this fraction. So we keep that limit because it's still required in there, so do not get rid of it. Okay, so then observe that in the numerator, I see that 7x minus 7x is in there, so that's going to yield 0 plus 7h, so I've just got 7h divided by h. And now I see that here I have the cancellations of the h, so this becomes the limit as h approaches 0 of 7. 7 is a constant, so as h tends towards 0, as this h becomes closer and closer to 0, it's not affecting the constant value of 7. And for that reason, whenever you have the limit of the constant, we know that the answer should be that constant that was in there itself. So the final answer in here is 7. And that is precisely what you would have expected for the gradient of a function 7x, because we know this is y equals to mx plus c, and the value, the coefficient of the x tells you what the gradient is. And here we see, well, the gradient to the curve at a point x is 7. Did everybody follow that simple example that we just went through? Wonderful. And I see that you had written down the answer of 7. So typically we're going to end up having some basic rules which will help us remove all of these calculations. So you would be able to know exactly what your answer should be at the end. But if you're asked to calculate from first principles, then remember, you have to show all of the work that we just did. So let's try one more example with first principles. I can guarantee you that in the exam, you are going to be asked to calculate the derivative of a function. They will give you the f of x, and they will ask you to calculate the derivative from first principles. You cannot avoid that question. It will be there. Okay. I'm glad everybody's following. So let's consider the following question. Let's look at f of x equals to, let's go with 3x squared. So this is my function. and I want to find out what is f prime of x, and of course, from first principles, right? We need to calculate. So we know that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Remember to always include your formula, right? You will receive a mark for this. Okay. So remember the question is 3x squared. So now we require f of x plus h. So let's do our calculation for that. So f of x plus h is 3 into, remember, you replace every occurrence of x by x plus h. Okay, so it becomes 3 into x plus h all squared. Oops, sorry, my window just moved. I hope you can still see it on your screen. There we go, looking good. So what we need to do is we now need to square the x plus h. What do we get in there? That's x squared plus 2xh plus h squared. All right. And then we can distribute the 3 into this. So this becomes 3x squared plus 6 times xh plus 3h squared. And so that is the final answer that we have here for f of x plus h. Does everybody agree with this bit? Okay. Great. Right, so now let's go ahead and compute. So remember what I've explained to you about your limit. Keep your limit in there. Do not omit it. Okay. I'm now going to put in what we just calculated for f of x plus h. So I've got 3x squared plus 6 times xh plus 3h squared. Now I need to subtract 3x squared, right? Because that's what f of x is. And then we divide by h. Great. So now when I'm looking at this, I observe that I've got 3x squared and I've got minus 3x squared. So what am I left with in the numerator? In the numerator, we just have 6xh plus 3h squared, and the denominator, of course, is just h. So look at what I'm doing. I'm not omitting any steps. I'm taking my time to clearly show what's being changed, how the 3x squared is now no longer there in the numerator. Of course, you could then, if you were working fast, you would be skipping a step, but make sure that you don't do that. Do not give an examiner or the marker, sorry, an opportunity to remove marks when you could have obtained full marks for a question. So put in everything, okay? You have the time to do it. So now I see in the numerator, I have h is common, so I pull that out, and I'm left with 6 times x plus 3h. And of course, I've still got h in the denominator. And now I see, well, there's a cancellation of the h taking place. And so this simply becomes the limit as h approaches 0 of 6x plus 3h. So now we're taking a limit of this expression, and observe that in this expression, there is indeed an h in it, okay? So because this is a polynomial expression, when you have a limit of an expression of this type, we can then substitute in the value for which h is approaching. So we then write this down as 6x plus 3 times 0. And so this is the point at which you can now remove writing down the limit, because the substitution has occurred. And so we see that this is just going to be 6 times x. Okay, so has everyone followed this? I think some of you had said that it is 6x in the chat box, so I'm glad we could all see that. Wonderful. Right, would you like to do one more example of this type? Let's take a look. I just answered this question, 3x squared. Right, so we just answered question 8.1. So this was last year's exam, the December examination, and it said determine f prime of x from first principles where f of x is 3x squared. And that is precisely what we had answered here. Okay, so this was question 8.1. So I'm just quickly looking at the chat box. Okay, yes, many of you have said, let's do one more example. Yes, so let's do that. All right, so we've done the question 8.1. We will come back to 8.2. Let's do one more example from first principles together. All right, let's see. What example would I like to use? Okay. Let's go with 1 minus 7x squared. Okay, so this is the function that I'm giving you, and we want to find out what is y prime, what is the derivative. So again, y prime, so if you view this as your f of x, of course, so f prime of x, we have our formula, is the limit as h approaches 0 of f of x plus h minus f of x divided by h. Right, so that's what we've got. Of course, we now need to spend some time calculating what is f of x plus h. So let's do that together. All right, so that is going to be 1 minus 7. And in place of x, I'm going to replace it by x plus h squared. Wonderful. So then simplifying, I see this is nothing but 7 into x squared plus 2xh plus h squared. And so this is 1 minus 7x squared minus 14x times h minus h squared. Is everybody happy with this? This calculation. I'm just waiting for some chat box responses before we move on. So that's the calculation that we've done here. Okay. Right, so let's proceed with our calculation. I see in the chat box. Wonderful. Yes, everybody's following. Great. So we've got our f of x plus h. I've got it there at the corner. So this is what we're going to put in when we do the calculation. So it is the limit as h approaches 0 of f of x plus h. So that now must go in, which is 1 minus 7x squared minus 14xh minus h squared divided. Okay, sorry. So I know that h is going to go in there, but what have I put into the numerator? I've only put in f of x plus h. So now I need to subtract, right? So I need to subtract f of x, and f of x is 1 minus 7x squared. So that's what we've got. So now let's simplify in our next step. So I see we've got some questions in the chat box. Isn't the last term supposed to be positive 7x squared? Oh, let's check. What did I do? Yes, wonderful. Thank you very much. Right, so looking here at f of x plus h, right? So we had computed x plus h squared, and here it is here in this bracket. So that's it there. And then we needed to distribute the 7 to each term in there. Okay, so actually it's negative 7 into each term. So when distributing, we get negative 7x squared, negative 14xh, and negative 7h squared. Thank you very much for pointing out that I didn't put the 7 in there. So let's put our 7 in here. So that has now been written down correctly. And then we've got negative. So we've got a minus f of x, which is 1 minus 7x squared. So are we all good up to that point? Everything correct? Right? Wonderful. So now we're going to simplify what we have. Okay. And so this is just 1 minus 7x squared minus 14xh minus 7h squared minus 1 plus 7x squared. So I've distributed the negative into the last bracket and we're dividing by h. So I'm just checking our chat box again. Wonderful. Everybody says they're all good. And here we now see I've got 1 minus 1. And in the second term, it's negative 7x squared. But in the last term here, I've got positive 7x squared. So I've got that these terms are now being absorbed, all right, in the numerator. So in the next line, when we're simplifying that numerator, I see that what we're left with is negative 14xh minus 7h squared. Do we all agree with that? So that has gotten rid of that. And this has removed this. So I've only been left with 2 terms in the numerator, and then we're dividing in the denominator. So now, in the next line, I observe that the numerator has a common h, which I could now factor out. And I'm left with negative 14x minus 7h divided by h. And as we had seen in our previous calculations, we've got the cancellation of the h occurring. And this leaves us with calculating the limit as h approaches 0 of the following expression, negative 14x minus 7h. Okay, let's check the chat box once more. Wonderful, thumbs up, so we're all following. And again, we reached a point where we've now reached this polynomial type expression. So in here, we have h approaching 0, and we certainly have h in this polynomial. So it's like a polynomial in h, where x is regarded as a constant in a sense. And so we can do the substitution. So we can substitute. So this becomes negative 14x minus 7 times 0. And we now drop the limit because we are doing the substitution. So at this point, we now see that we arrive at an answer of negative 14x. Is that the answer that you all thought that you would have gotten for this calculation? The function was 1 minus 7x squared, and we've arrived at an answer, a final answer, that f prime equals to negative 14x. So that's what we've got. So essentially what this is telling us when we arrive at things like this is it's telling us that the slope of f at a point x is equal to negative 14x. So for any x value that you substitute in, you would be able to determine the slope of the function f at that given x. So if I wanted to know what is the slope at x equals to 2, so then you would be able to tell me, so at x equals to 2, so let me write it like that. At x equals to 2, the slope of f of x is, and it's given by f prime at 2. And what is f prime at 2? This is equal to negative 14 times 2. And that's not, and that's just going to give you a value of negative 28. So that is the slope of the curve f at x equals to 2. Does everybody follow that reasoning? Are we all happy with our first principles and our interpretation of what the final answer is giving us? Great. Okay, we're getting thumbs up. Wonderful. Okay, and so let's summarize and let's end with our basic rules. So our basic rules, so remember, we want to answer this question, 8.2. So basic rules of differentiation. So the first rule is that 1, derivative of a constant. Okay, so what is a derivative of a constant? So if f of x equals to some number c, the question is, what is f prime of x? Okay, so what is f prime of x? So what we could do is we could quickly go back to first principles and we could derive it. Okay, that's what we could do. So f prime of x will then be the limit as h approaches 0 of f of x plus h minus f of x divided by h. And so what is that? That is the limit as h approaches 0. What is f of x plus h if f of x equals to c? Can you tell me? Type it into the chat box. I'd like to see. What is f of x plus h when the function f is equal to c? So you're typing in zeros because that's the final answer. Wonderful. And now I see that we've got you typing in c. Perfect. So that is equal to c, right? So what I'm referring to here, this is c. Right? So we've got c in here, and then we're subtracting f of x. So we're also subtracting c, and then we're dividing by h. So look at what we've now gotten here. We've got c minus c. So this is the limit as h approaches 0 of c minus c, which is 0 divided by h. But what is 0 divided by anything? Let's look in the chat box. What have you got to say? 0. Wonderful. So we now have that we're calculating the limit as h approaches 0 of 0. 0 is a constant. And as I had explained to you earlier, when you're taking the limit of a constant, the answer is 0. Sorry, the answer is the constant. And here the constant in particular was 0. So therefore the answer is 0. So we have seen from first principles that the derivative of a constant is 0. And that's a very nice rule to have on hand. So if you had to look at an example, so let's just say I told you f of x is equal to 2 pi. And I asked you, well, what is f prime of x? Can you tell me what that is? Is 2 pi a constant? Yes, okay, so we're getting some responses. Similarly, if I squared this, it will still be a constant. If I cubed it, it would still be a constant. So the derivative of a function of that type is 0. So keep that rule in mind. The next rule that we want to discuss is the power rule. Okay, and what the power rule tells you is the following. If f of x equals to x raised to the power n, then f prime of x is equal to, so you take the power and you write it down as a coefficient. You then multiply to the variable x. And what we do is we adjust what was in the power. So we put the n down, but we then subtract 1. So we have 1 less in the power. So that's what we've got. Let's take a look. There we go. Right. So again, this can be derived using your first principles formula, where we will end up coming to this point that the derivative is nothing but n multiplied to base x raised to the power n minus 1. So now let's look at examples. So one of the questions from the past paper, let's go and look at them. The past paper said, calculate f prime of x if f of x is equal to the following. So let me see if I can copy that. Paste it. Wonderful. So here's the question. This is what we want to calculate the derivative of. So I've got f prime of x. Okay. So we're going to use our basic rules that we've just learned. From the basic rules, we've learned about what is the derivative of a constant and what is the derivative of a function of a specific type, of this type, where it's base x raised to some power. So observe that in the first term here, I've got base x raised to some power. In the second term, I do have a constant, but in the third term, it doesn't look to be of the form base x raised to a power. So how do you think we're going to change that? Are there any rules that you have learned before that helps us write this down in a different way? Okay, so let's recall that whenever you have something written down in that way, in fraction form, we could rewrite it as base x raised to the power negative n, or likewise, analogously, if I had the following, then I could write that down as base x raised to the power positive n. So these are some really nice interchangeable rules that you could utilize. So before we calculate the derivative, what we would end up doing is we would focus on rewriting this in a nicer way so that we can quickly calculate the derivative. So I see that there's no problem with the first term. There is no problem with the second term. And so now I'm going to adjust the other term. So this is nothing but 9 multiplied to x raised to the power negative 2. Is everybody happy with that? Let me check the chat box. Great. And so now we can compute the derivative. So the derivative is f prime of x, and this is equal to, now utilize the rules we've just learned. What is the derivative of x squared? The rule here says write down the power as a coefficient, so that becomes 2. Then I must multiply to the variable x, and then I must raise that to the power 2 minus 1, which is 1. Great, everybody agrees that it was 2x. Then what is the derivative of a constant? We saw that that was 0. Okay, so I'm just going to say, well, we could say minus 0, since there was a negative there. And then what is going to be the derivative of 9x raised to the power minus 2? So I can write down this 9. And then I can focus on calculating the derivative of x raised to the power negative 2. So let's calculate that derivative. What is that derivative equal to? So based on this power rule, we write down the power, which is negative 2. I write down the variable, and I look at that power and I subtract 1. So what is minus 2 minus 1? Minus 2 minus 1 is minus 3. And so this is now what we've gotten. So let's simplify. That is 2x plus 9 times negative 2, which is negative 18, times x raised to the power negative 3. And so this could essentially be the final answer, But whenever you write down your final answer, we typically do not like writing down negative exponents. So what we'd want to do is write down a positive exponent. Okay, that's what we want to do. So how do we go about writing this back down in a positive exponent? We utilize this rule. Can you see that this rule is required? So that's 2x, that is fine. And this is minus 18. So how do I convert x to the minus 3? Oh, sorry, not that rule. Let's utilize the first rule. So I've got x raised to the power negative 3. So it's going to be written down as 1 divided by x raised to the power positive 3. Do we all agree with that? Let's take a look. Okay, Natanya would like us to explain this problem one more time, and then I see some other responses that yes, you've understood that bit. So let me complete the problem, Natanya, and then I'm going to go back to the beginning and summarize what we've done. Okay, so then in the last step, this is just 18 over x cubed. And so that's the final answer. So what did we end up doing? We were given f of x, and we were required to calculate its derivative. So this was f of x, and it was clear that based on the rules that we had, that this third term here, that expression needed to be rewritten so that I could utilize the power rule. So it wasn't clear how this rule was going to be used. So utilizing these tricks that I had written down on the side, we had rewritten. So this here is just 9 times 1 over x squared. I hope you see that. And using this rule, I had 1 over x squared. I see that it can be written as x raised to the power minus 2. And so that is why we get 9 times x raised to the power minus 2. Natanya, is that helpful? Okay. And so we had rewritten f of x as x squared minus 3 plus 9 times x raised to the power minus 2. In the next step, we're now computing the derivative. What is the derivative of x squared? Oh, wonderful, Natanya. I'm glad it was helpful, right? So x squared, and so using the power rule, we see that that is going to be equal to 2 times x raised to the power 2 minus 1, hence why we got the power of 1. Then we know that the derivative of a constant is 0, so I wrote down 0. And then we computed the derivative of 9 times x raised to the power minus 2. So I wrote down the 9, and then I focused on calculating the derivative of x raised to the power minus 2. So the power rule says write down the power, which I did. I wrote down minus 2. It then says write down the variable, and then in the exponent, write down whatever was there previously minus 1. So it's minus 2 minus 1 giving me minus 3. And then in the remaining steps, we spend some time simplifying that. Okay, guys, so it is now 6:30, and I hope that you enjoyed this lesson. There was one more question that was in that exam, so perhaps you could take it down and attempt to answer that one on your own, simplifying as much as possible. We will make this recording available on YouTube, so please ensure that you subscribe so that you get updates on the upcoming videos, as well as we will try and make these notes available to you to be sent to you via email. So I hope you enjoyed the lesson. I did enjoy teaching you today. So have a wonderful evening, and don't forget that we've got one more upcoming lesson which will take place in 2 weeks' time on a Thursday evening at 5:30. So I look forward to seeing you all then. Thanks again, everyone, and goodbye.